In this video, we're going to go over functions and function notation practice problems. Remember, a function is where an x value maps or goes to only one unique y value. And an x value cannot map to more than one y value. So let's look at the following two examples here. So are the following functions or relations justify reasoning? So if we look at this graph here, does every x value have only one y value? So we check that by doing the vertical line test. And this test helps you determine whether or not something is a function. So if you draw a vertical line anywhere on this curve, does it hit more than once? Because if it hits more than once, then that x value has two different y values or more. In this case, if I draw a vertical line here, if I draw it here, I can't seem to find a spot where I can draw a vertical line where it hits more than once. So therefore, this passes the vertical line test and becomes a function. Okay? So every x has a unique y value. So every x has its own y value. Now if we go over to the second one where the table is at, if we look at the inputs and outputs, we have 3, 4, 5, 4, 10, and that maps to 0, 7, 10, 14, 25. Always be on the lookout for inputs where there's a repeated input. And in that case, it's 4, 4. This 4 maps to 7. This 4 maps to 14. That is the same x mapping to two different y values. That is not a function. You cannot have that happen. This is a relation. Still some kind of relationship here between these two inputs and outputs, but you can't call it a function because this x value maps to two different y values. All right, let's look at number 3. You make a table with the inputs being students' heights and the outputs being the number of siblings each student has. So if my x value is student height and my y value is siblings. All right, well, it would help to kind of figure out first, do you think there's a relationship between student height and siblings? And then try to come up with an example where it would make it kind of disproving that it's a function. So first of all, is there a relation between student height and how many siblings they have? No. Nothing going on there between those two variables. In fact, you can even think of if somebody were 5'10", and they had 3 siblings, and let's say somebody else was 5'10", but they had 0 siblings. This is possible. And because it's possible, we can say that this is not a function, but this is a relation. In this theoretical case, we have made up a single x value mapped to two different y values. So this is a relation, not a function. Number 4, you make a table with the inputs being different distances a single student has ran, and the outputs being the length of time it takes the student to run each of those distances. So my x value is the distance that the runner runs, and y is the time it takes. Okay? So if I have the same student run all these different distances, one would assume the same student would run the same speed. So if this student ran 10 meters and their time was 2 seconds. If they ran 20 meters, maybe their time is 4 seconds. All we know is that in 10 meters, we know it's going to be 2 seconds again. This is the same x, but it maps to the same unique y. This becomes a function. We can't really make up in an instance where we have the same distance with two different times, because then it's not the same student and it kind of goes against what the problem is telling us. This would be the same student running the same speed, so that the same distance would produce the same exact time. All right, so the second part here, we're looking at function notation and evaluating functions using function notation. So we're looking at this problem here. It says to find the error in the student's work, state it, and then solve the problem correctly. So if I'm looking at this is my function notation, nothing wrong there. This is f of -2, which means every time you see an x, you replace it with -2. So if I'm looking at this top part here, I'm replacing that with -2, and same here as well. So I do see a -2 replacing both those x's. The problem is they've written it as subtraction. This is -3 times x. So that should be -3 times -2. This should be -2x, -2 times -2. So they've written multiplication as subtraction. And then that's a no-no. You cannot do that. So when you plug numbers in, we always teach that you put them in parentheses, always. So this x gets a -2 parentheses squared. -2 parentheses -2. So this is what it should look like. And then now you can go ahead and start evaluating. -2 quantity squared is 4. So you have -3 times 4. -2 times -2 is a +4. Finally, -3 times 4 is -12. -12, 4, and 5, we're going to add up to make -3. So f of -2 is equal to -3. So these next two, 3 and 4, we're evaluating for a given input. Replace whatever x you see with -3 in this case. And we only have one of those. So f of -3 becomes 9 times -3 minus 10. So only two operations here. First one is multiplication, following order operations. And then -27 minus 10 is going to be -37. So f of -3 is equal to 37. You can also think of this as an ordered pair, -3 comma -37. So number 4, we have f of -3 for this function, 10 minus 2x squared. So this is going to look a little bit different. Still the same process. You're going to repeat this. You're going to replace every x you see with -3. In this case, there's only one of those. And as I plugged it in here and as I plugged it in here, both have parentheses around the input. So f of -3 is going to be equal to exponents first. So -3 squared, or quantity squared, is going to be 9. Multiplication before subtraction. This becomes 10 minus 18. And 10 minus 18 is -8. So f of -3 is -8. This problem is going to be a application problem where they give you a situation and actually give you a function, and then they're going to ask you a couple questions after that. So this says Martin spends $8.50 per CD that he buys online, along with a one-time shipping cost of $10. His expenses for CDs this week are represented by the function f of x equals 8.50x plus 10. How much would he spend if he bought 4 CDs? So this is important. What is 4? Is it the x, the input, or is it the output? Well, if we look at this, this says his expenses for the week are represented by the function f of x equals 8.5x times 10, or plus 10. If you're multiplying 850 times x, it's 850 per CD. So that means for one CD, it'd be 850. For 2, you would do 2 times that number. And because you're doing that multiplication here, that's how you know the x value is number of CDs. And also this plus 10, that's the one-time shipping cost of $10. That means you pay it only once, not multiples of x. So how much would he spend if he bought 4 CDs? Well, it'd be f of 4 is equal to 8.50 times 4 plus 10. Order of operations here, 4 times 850 is going to be 32 plus 2, 34. And it's going to be equal to $44. So that's $44 he has spent. So how much would he spend if he bought 8 or 10 CDs? It'd be f of 10 And it'd be $850 times 10 in parentheses plus 10. $850 times 10 is 85 plus 10. And when you add 85 plus 10, it's going to be 95. So his total expenditures for the week are $95.